Hello. Hello, I'm audible. Hi, I'm audible. Please reply. Good evening, everyone. Hello. Hello, I'm audible. Okay, good. Good evening, everyone. Okay, so okay. Good evening, everyone. So today our objective is to basically give you exposure on like how to start the project on digital, and with the help of that digital project, how you can start using FPGAs. Okay, so now the session is going to be very interactive. Why? Because of two reasons. One, that whatever you are learning, okay, whatever you are learning in terms of digital, it is not just a theory. It is not just a theoretical, right? It is something like, with the help of digital, how you can control a device which we call FPGA generally, and but the part or the use we are going to uh, perform here is a very small part on FPGA side. Okay, so this particular things I am doing from last 11 years. Okay, with the help of this academic in these academic sessions, mainly we are trying to give you exposure like what is FPGA. Okay, what is the use of FPGA, what is the advantage of FPGA, what is the disadvantage of FPGAs. Okay, and what are the different components basically, or it is something like that. I can say what is the architecture of FPGA, what is the complete flow of the FPGAs. Okay, and not along with this schematic. Okay, with digital components, you can also use FPGA with the help of HDL, with the help of C, embedded C, and with the help of MATLAB. Okay, so what challenges I have faced here, that people from first year, second year, third year, fourth year, they are not aware of the FPGAs. Okay, they aware of the Arduino, they aware of the Raspberry Pi. Okay, they aware of the embedded, they aware of the quadcopter, they aware of the drone, they aware of everything which is available in this industry, but they are not aware of the FPGAs. Okay, again, what message I want to give here, that to control the microcontroller, you have to learn, you have to understand the C. Okay. But suppose that if any candidates don't have any interest or he or she not able to make the logic using the programming C. Okay. And if he or she is from very rural background and there is no exposure of programming in 9, 10, 11, 12, even in first year, second year, right? So he or she can't use the microcontroller because microcontroller is something where you have to write the code in C. Before that, you have a good understanding on C. Okay. But if you don't have a good understanding on C, you can't learn, you can't control the microcontroller with help of the microcontroller registers, which are provided by the manufacturers. So the biggest challenge is what I have seen in my entire journey, that people are easy, they are easy to use the Arduino Raspberry Pi, but I found out of 10 only one or two who knows the STM32, who knows the TI microcontroller, okay, who knows the 80 mega and who knows the AVR, etc, right? Because there they have to write a code in C. So this is one thing, this is one approach. But when I entered this domain, I started pitching FPGA because I'm from FPGA background. But again, the challenge is same. Please try to understand. Here again, many of the industry professional knows that key FPGA can be controlled by with help of Verilog and VHDL. Even in my journey in 2003, 2004, 5, 6, 7, I too started learning the FPGA with help of HDL, right? Verilog and VHDL. But again, the same challenge I face on microcontroller, that people should know to how to control the FPGA with help of, sorry, how to control the MCU with help of C. The same problem I face here also. To control the FPGA, you should know the Verilog and VHDL. So again, the programming came. Okay, again, the programming came in a picture. So many of us, 9 out of 10, 5, 6, 7 people are saying, sir, programming to nahi aati, how to proceed. But I want to learn FPGA. So then I implemented, then I introduced a schematic entry, demux, encoder, decoder, towards complement, etc. We are going to make some 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 design, okay, which give the real time output and which take the real time input. So now what is schematic? What is schematic? Schematic means it is something connected with the component which you basically call and place in the breadboard, okay, or in a workspace. Okay, schematic. What is schematic? Schematic means a digital component, okay, digital component which you will place in your workspace or breadboard. This is your workspace. Okay, you will call the component and you will start connecting it and you will make the different logic. For example, the best example is your 4-bit adder or 8-bit adder or full adder, right? So in full adder or in 8-bit adder, so in full adder is made up of your components. With the help of full adder, 1-bit full adder, you can make a 4-bit adder, and with the help of 4-bit adder, you can make a 8-bit adder. Okay, so all these things you are designing on paper. Now the biggest challenge designing on paper is little bit complex because you cannot control the all the output. You cannot save all the output, previous output in your mind. You have to write it somewhere. Okay, that is why a tool came in picture for this schematic entry. A tool came in picture, tool from Xilinx. Okay, what is Xilinx? Okay, Xilinx is an FPGA manufacturer. Okay, they basically they basically design and produce the FPGAs which work on basically the digital logic. Field programmable gate array. Xilinx acquired by AMD. Okay, I'm giving you the introduction that what we are going to do it now. This is our second phase. Okay, so uh, Evening. Okay. So Xilinx founded somewhere in 1983, 1984, somewhere is a US based company. Okay. So Xilinx has one tool we call ISE, Integrated Software Environment. Okay. Integrated Software Environment. ISE has two features. One is schematic and one is HDL. Again, the challenge will come if anyone is not aware of the Verilog, or he or she has don't have any interest on coding side, or he or she has not performed anything previously on HDL side. Then there will be a challenge for him or her to understand the HDL. But this schematic, if you don't know the HDL, if you don't know the programming, if you don't know the MATLAB, right? Still you can control your FPGA. Okay, so what is the advantage here? If you control your FPGA with your digital design, with your digital components, right? You will never forget. You will never forget your digital anywhere in your entire life. For example, I'm going for an interview, okay, or in any college for any workshop. I'm in class. I'm in fourth year. I basically ask anyone, okay, what is the flip flop doing? What is latch doing? What is mux doing? What is demux? What maximum reply basically I received, sir? I have gone through in second year, third sem, fourth year. Sir, I don't remember now. That is the biggest problem in our student because they learn and they forget. But if they have designed something for 6 months, they will never forget. Okay, it is something like that. I am part of a crowded city. Okay, and I am not aware of the every road inside. So that will be a very tough for me, right? But if a person is born and brought up in that crowded city and that person is is aware of the each and every road, inside road, outside road, then he or she, if he or she is coming after 5 years, 10 years, he will never forget or she will never forget the road. Why? Because he or she has personally visited each and every place. The same thing is happening, is going to be happen here. If you have designed something like full adder, half adder, subtractor, mux, demux, okay, comparator, 2s complement, if you have designed something and you have implemented it on an FPGA and you have received some output, you will never forget the entire digital in your life. And this is the biggest gap in our education system, that we know the project in analog, we know the project in HDL, we know the project in top PD domain or in top embedded domain, but we don't do any project on digital side. Why? Because digital is just for reading theory. No, it is not like that. Digital is, you can also do the project using digital components, and this is the first step for every engineer. Okay, this is the first step. If you guys are following me, whatever I'm going to do it in first year, second year, people will start taking the interest in digital, and with the help of digital they will start taking the interest in entire VLSI domain or entire embedded domain, and they will never think about the any third domain, any non-core domain. Okay, so this is my thought. Whomever I have taught how to design the project in digital, they are never think about the any other domain unless until they have very much pressure from their family to take the job. Okay, so now let's start. Okay, so as I mentioned in digital, what is going to be our project? So I can't do much thing here, but I will definitely uh, design one project with help of you guys. Okay, and we will implement it on FPGA. We will show you each and everything, even FPGA flow, FPGA architecture we are going to discuss. This will take the time. Okay. So my idea is to make a project with help of digital. Then the same project we will design with help of Verilog or VHDL. Okay. And both thing is going to implement on FPGA. So if you're going to follow me next 10 class or next 15-20 class, you have a very solid resume. This is my promise to you. Okay. So in digital combination, I already discussed one project in sequential. So my plan is to do at least at least sign calculator, and sign calculator is divided into two parts. Part A is A plus B, means adder and subtractor, and part B is multiplier and divider. Okay, so we are going to do this only from designing to implementation on FPGA. Okay, and this is going to be take time. And in sequential, we are going to design a project like your LED blinker, at least, or at least one stopwatch. Okay, so this LED blinker and stopwatch is going to implement on FPGAs and not on just a theory. No, this this one or any one of this is going to implement on FPGA. I will show you. Okay, so let's start the first project. Any question? Let me see if you have. Okay, how to download Xilinx IC? Everything I will give you, Prince. Everything I will provide you. All the tools, how to install, first how to download, how to install, each and everything. All instruction I will provide you. You don't have to worry. Okay, you will, because see, ISC is totally obsoleted by Xilinx. Now it is AMD. Okay, and they are focusing on Vivado. So Verilog and VHDL, we will focus on Vivado. Okay, so I will give you the brief demo how to use the Xilinx ISC and how to use the Vivado. Okay, at least the complete RTL flow I will help you. Even if it is required, I can also guide you how to use the ILA there in a using the Vivado, that is an integrated logic analyzer, and the same ILA is also implemented in a ISC also. Okay, so wait for some days. Okay, you have to be very patient. Okay, so let's start. My first project is sign calculator. Okay, I already gave a small introduction previously. Okay, so for this sign calculator, I required, as I mentioned, I want two operations, A plus B and A minus B. Okay, this I already given a small introduction in previous class. Now I am going to take a session in detail. So A plus B means you have two input. Okay, so whenever you are going to design any project, okay, first you finalize the, okay, not finalize, I will take in terms of what is flow, FPGA flow, or sorry, what is a project flow. So first you implement the idea, what you have to design, right? क्या आपको बनाना है? What you have to plan. So my idea is I want to implement a calculation between two input, and then I will add the sign to get the sign output. So this is my idea. Then what is my specification? So my specification is two input, two input, one output. Input is 2, output is 1. Okay, and plus sign and unsigned. Sign and unsigned input and output is my specification. Now, how to design or design part? Okay, design either you do with the help of HDL or you do with help of schematic. Okay, so we are going to do it with the help of schematic. Okay, I have to input A and input B. Okay, of 4 bit. Please remember this is a 4 bit. 4 bit means A is 9, 9 means 1001, and if B is 5, then 0101. Okay. Then I have another specification is sign and unsigned. Sign means I should get output in negative. Okay, depend on my input. And unsigned means I should get my output in positive. Okay, depend on my operations. And what is my output? Output is of 8 bit or 9 bit, depend on my operation. Okay, depend on my operation. Okay, so this 1, 2, 3 are my specification. Okay, now to design this, what we required? We required adder. Okay, we required subtractor. We required mux. We required demux. We required decoder. Okay, and we required 2s complement. Okay, so as a designer, you have to use all these components. You have to use all these components, and you have to design the architecture. That is the engineering. Okay, that is the engineering part. You have to do it, right? So first thing, let's start with adder. So what I'm going to do here, how I'm going to proceed? I will first take the concept of each and every component. Then we will take some interview question on each and every concept. Okay, because this is also required. Interview question. Then we are going to implement. We are going to implement on tool, right? And then we going to check our verification. That is a simulation. Okay, verification means functionality verification, functional verification. Okay, whatever I want. Okay, whatever I'm going to design, whatever I want, whether the output is correct or not, and if it is 100% successful, then we go for the FPGA implementation. Okay, so this is my plan, right? This is my plan. Now adder. So what is adder? Adder is a basically a device, or adder is basically a circuit which is made up of gates and which perform the addition operation. Okay. For example, adder, again, adder is a device. Okay, you can say adder is a device. Okay, why I said a device? Why I'm not saying as a component? Okay, so there is two things. A single device I can, or a single element I can call as a component. Okay, and with help of many components, like with many gates, I can make one circuit. And this circuit I can call, because this is up to your understanding how you are going to represent it. Okay, I basically call adder as a device because it is made up of the different components and there is a proper circuit inside the device. Okay, so either you can say circuit or you can say a device. Okay, so don't be get confused. But if a single adder is look like this, okay, a single IC, then you can call this as a component because it is now looking like a very single component. Okay, so it is up to your understanding, however you are going to take up. Okay, so adder is basically a device. Okay, is a device which has two inputs. Please note. I know there is a question in your mind. I have read three input, but now why sir is saying two input? There is a question. There is always question in your mind. So adder is a device which has two input of single bit. याद रखना, it's of single bit or multiple bit. Okay, which is of single bit or multiple bit and which perform the operation of addition. Okay, for example, This is my A and B and addition, and it gives two output. It gives two output. One output is sum and another output is carry out. Please note, a carry is at both end, right? So carry word is also available at input end and carry word is also available at output end. So you have to be very, very cautious while speaking, because interviewer is not judging how you are designing. It's also they also judging how you are communicating it. Okay. So if you say carry at output side and if you say carry at input side, that means you are not prepared well. Because if you are doing the mistake here, definitely you are going to do the mistake in design also. So carry in and carry out. So you have to differentiate in proper. That is why I have written a carry out. Okay. So A and B, this is my sum and this is my carry out. Okay. So 0 0 0 1 1 0 1 1. This is my sum and this is my carry out. So when you add 0 plus 0, this is 0. When you add 0 plus 1, this is 1. When you add 1 plus 0, this is 1. And when you add 1 plus 1, okay, you say, sir, this is 0, 1. Okay, so sometime I ask the questions from the candidates. Okay, make the truth table, write the sum, write the carry out. Then my question is, why we consider this as a sum and why we consider this as a carry out? Okay, the first interview question will start from here. Why I am taking this as a carry out? One. Why I am not taking one as a sum? Okay. So interviewer can ask anything. You can't expect he or she is going to expect the only the circuit diagram. Okay. And this should be come in your mind. While preparing the notes, you are just making the notes. Whenever the lecture is going on, you are just making the notes. Don't make the notes. Think first and then prepare the notes later on. Okay. So why this 0 is here and why not 1 is here? Okay. So this always comes in your mind, right? Uh, I will definitely share the reply, but I want you to think. Okay. You just have a thought. Why 0 is coming to some side and why this 1 is coming to this side. Okay. Later on, 0 0 0 0 1 0 1 0. Okay. So this carry out basically. Okay, so this 1 will come here. Okay, so basically this is 1 plus 1 means 2 and 2 का binary हुआ 0 1. So basically it is like this. Okay, so why this 0 is here and why this 1 is here? Okay, you should ask. The question should be anything. Don't worry. Be open. Don't think that my question is silly question. And my friend will ask, will laugh on me. Okay, forget it. Don't worry. Okay, कुछ नहीं होता. हंसने दो लोगों को. Let them laugh. But you should ask the question. Okay, so please think and let me know later on in comment or later on there in recording or in WhatsApp group. Why 0 is at sum and why C out is 1. Okay. So this is my sum and carry out. Okay. Now this is giving the output of this is giving the output. This is basically a XOR. Okay. And this is your AND gate. Okay. So now my second question. Can anyone can judge what is my second question? What is my second question here? Can anyone judge? Can anyone judge what is my second question? See, in I as I mentioned here in project, I want adder, subtractor, mux, demux, decoder towards complement 8 bit. ठीक है, मुझे इस प्रोजेक्ट को बनाने के लिए टू इम्प्लीमेंट द साइन कैलकुलेटर आई नीड अ 8 बिट कैलकुलेटर. ओके, बट आई एम स्टार्टिंग विद द हेल्प ऑफ half adder. So let's see. So anyone can judge what is my second. No, it is easy. This is simple. A and B. So my question is, let me ask from you. How many NAND gates? How many NAND gates is required? How many NAND gates is required? See, this is the interview question. As I mentioned, that how I'm going to proceed. Concept, that is theory, plus interview question, plus implementation, plus verification, and then FPGA implementation. Okay. So how many NAND gates? How many NAND gates required to implement a 1 bit half adder? Any idea? How many NAND gates required to make a 1 bit half adder? Why I am calling 1 bit? Because this is single bit, right? This 0 0 0 0. This A is 0 single bit and B is single bit. That is why I am calling as a 1 bit. Come on, tell me. 5 NAND gates. So doubt your name. I'm not sure. So this 5 is your maximum NAND gates or minimum NAND gates. So you should ask, sir, you want to know maximum or minimum? You want to know maximum and minimum. Tell me. ठीक है, मतलब if I am an interviewer and you are a candidate, you should ask the question, sir, you want to know the maximum or minimum? Come on, Atul, this is the maximum or minimum? You have mentioned the 5. Okay, now tell me, this is the maximum number of NAND gates or minimum number of NAND gates? Come on, my dear. Atul, Prince. No, tell me this 5 is 5 is a correct. But here there is a 2 reply. One is maximum, one is minimum. Now tell me this 5 is a maximum or minimum? Minimum. Okay. 5 is a minimum. Okay, correct. Now what is the maximum? Now what is the maximum? Come on. No, Avik, max. No, wrong. So I have mentioned this 5 is a minimum, correct. 5 gate is required. Now tell me how many gates, maximum number of gates required to make a 1 bit half adder with the help of NAND. No, Prince, not 9. Come on. No. Okay. That may vary. No. Okay. Now let me explain here. Whenever the question will come like this, tell me the maximum and minimum number of NAND gates required to make any circuit. And this circuit can be a half adder, full adder, half subtractor, full subtractor, mux, demux, encoder, decoder. Okay, whenever the such question will come in picture, okay, or any type of latch, any type of flip-flop, any type of counter, any type of, then in that case you have to think for only those implementation which are designed with minimum number of NAND gates. For example, if you remember in my first class, I told you how to make a AND gate with the help of NAND. This is your NAND. So this is the minimum number of NAND gates. This is sorting is required. I guide you in different way. I guide you how to design your own gate. That is a different approach. Now here the approach is how to basically you have to tell me the minimum number of NAND gates. So you have to use those gates, okay, which are already designed with minimum number. That is with help of sorting. Okay, so and required 2, right? Or required 3. OR required 3. Okay. XOR. XOR required 4. So all those who have said 5, now tell me how you have received 5. Okay, so this is 4, this is 3. एक और आगे लगा देंगे तो it become XNOR. This is 5. Okay, so now my question is maximum is basically 6, minimum is 5. Okay, so how we are going to implement this? Okay, this is your XOR. Okay, this is your XOR. This part. Okay, this part. This is your XOR. Okay, now take A and B from here, and now this is your AND gate. So the question is, the interview question is, see out how many maximum number of NAND gate is why generally prefer gate when compared to NOR gate. Why generally prefer NAND gate with compared to NOR gate? No, I don't think as such anything. But if I know the reply. Okay, I know the reply. Okay, but I don't think how much you understand. As per my understanding, NAND gate generally give a right positive edge. Okay, so as such, there is no reply on this. Ki why? If you know, then you can please let me know that why we prefer a NAND, not NOR. Okay, so as such, it is not like that. Okay, but yes, the NAND gates give a positive edge and NOR gate gives a negative edge. Okay, so this I will let you know whenever we will start the sequential. So let me first finish it here. And this is my end. So total number of 6, right? So now the question is maximum is 6, minimum is 5. So whoever has said 5, okay, yeah, I'm getting so many reply. This is good, very good that you guys are participating. Okay. Now whoever has said 5, now can you please tell me how you are getting the 5? How you are getting the 5? Now tell me, Atul, Kishore, now tell me how you are getting the 5. Any idea? NAND and NOR are universal gates, but there is other this also universal. You don't sing with that gates. I didn't understand. Doubt what you want to say. Okay. So okay, I will take up. You can talk to me here later on. Okay. So now the question is how the file basically came. Very easy. Okay. So now we are moving towards optimization. Okay, we are moving towards optimization. So the best example of optimization is your adder subtractor. 1 bit adder, 1 bit subtractor, both half and full. How? We have to reduce any one gate. We have to reduce any one gate without without disturbing the output. You have to remove any one gate without disturbing the output. So this is gate number 1, 2, 3, 4, 5 and 6. So you have to remove any one gate. So if I take the output, see what we are getting here, we are getting A dot B bar, and same you are also getting here also A dot B bar. Okay, so if I disconnect this, if I remove this, and I should take the output from here to here. Okay, so now I have only 5 gates. So the maximum number of gate is 6, and minimum number of gate is 5. How? If we can reduce this particular gate, or we remove this particular gate, then what will be the my output? Yes. Okay. Now let me help you with the demo. Okay. Let me introduce the tool with the same example. Okay. So my screen is visible. This, please say yes or no. Okay. So this is your Xilinx ISC tool. Okay. Project Navigator. Okay. So this is your Xilinx ISC tool, Project Navigator. Okay. So with the help of this tool, what we can do, we can design any number of or anything whatever is in my mind. Okay, so the logo is look like this of the Xilinx IC Navigator. This is the logo. Okay, IC design suite 9.14.7. Okay, I will give you just demo. Okay, I will not introduce the tool here because that I will take later on. Okay, so I will make one project, new project. Okay, I will write, I will set the location. Let's set the location here, new volume, make a folder, online live YouTube. Okay, so I have set the project name. Okay, then I will give here the, basically I will write here what is the my project name. Okay, the top